Good evening, 6th grade math class. Today's mini lesson is on factors and the distributive property. Probably from this title, you understand the word factors. Distributive property may need a little talk. So if you will do me a favor, please pause the video, write this title down in your math notes, and then unpause after you've done that, close the math notebook, and you're ready to concentrate and think. So before I start with factoring on this, let me just tell you what the distributive property means. The distributive property means, if you were to see a math problem like this, let's say, that there's two ways that you can solve that. There's two operations here, right? We have multiplying and we have adding. One way I can solve that is I can add the 4 and the 5 and make 9. And then multiply by 3 and get 27. That's probably the way you would normally think to do that. And then another way I could solve this is I could think of this as 3 times 4 and do that plus 3 times 5. And so 3 times 4 is 12 and 3 times 5 is 15. And those add up to 27. Same thing as over here. So I can do that either way. I can add, then multiply, or I can multiply 3 times 4 plus multiply 3 times 5 and get the same thing. So with factoring, let's go into what that has to do with factoring. So in our factoring lesson, we did this problem. So in our last session, we discussed a problem where I had 45 Skittles and 30 Starbursts. So basically I had 45 plus 30 pieces of candy. That's what, 75 pieces of candy, right? And I wanted to make bags with equal numbers of each to give out. So what I can do, I can take this and I'm going to rewrite this in some way that looks like, if I go back to the first slide, some way that I could use the distributive property. I'm going to have something times two things added up. And the two things added up are going to be my Skittles and my Starbursts. And the thing that ends up out here is going to be my bags. So let me show you how this works. And so I think one of the ways we figured out that these had a common factor of 5. There was several ways we could do that. And if I did 5, this is Skittles, Starburst. If I did 5 bags, that would mean I would have 9 Skittles and 6 Starburst in each bag, right? So a way I can write this, I can, remember this was going to be 75 pieces of candy total. I could rewrite this as 5 bags, 5 sets, 5 times, and each bag is going to have 9 Skittles and 6 Starbursts in it. And if you'll notice, 5 times 9 is my 45 Skittles. That's all my Skittles. And 5 times 6 is my 30 Starbursts. Remember I said before, two different ways you could, this is what we're looking to do. This is like I use the distributive property to write my answer to this question another way. 5 bags and each is going to have 9 of these and 6 of these. And either way, this is going to be, remember I told you there's two ways you could think about this, right? Do your 9 plus 6, that's 15. Then times 5, and you'll get 75 pieces of candy. 75 pieces of candy. Or you can do 5 times 9 plus 5 times 6. And that's this, right? 5 times 9 is 45. 5 times 6 is 30. And I still am accounting for all 75 pieces of my candy. Now, I didn't have to pick 5 here. Remember, we found out they had some other common factors too, like, say, 15 was one, right? So we also decided I could make 15 bags. And if I did, this one would have 3 Skittles. I'm sorry, each bag would have 3 Skittles. And each bag would have 2 Starbursts, right? So another way I could write this with the distributive property is I'm going to have 15 bags, 15 sets, 15 times, and each one is going to have 3 Skittles plus 2 Starbursts. And that is another way I could rewrite this out. It just depends what I factor out. Do I want to factor the 15 out of the 45 and the 30, or do I want to factor the 5 out of the 15 and 30? And I think there were other options too. I'm just going to present 2. All right, let's open your notes up and let's do the next one in your math notes, shall we? So the next situation we did last week was this one. This is our last session. We discussed a situation where 50 children and 20 adults came to a scavenger hunt. So I had 70 people altogether, 50 children, 20 adults. And I wanted to make groups for the scavenger hunt with an equal number of kids and adults so that they could divide up. So we looked for some common factors, and one was 10, right? We decided I could make 10 groups. And if I made 10 groups, then there'd have to be 5 children and 2 adults in each group. So if I write that with the distributive property, that means I have 10 groups, 10 times, 10 sets, and each set has 5 children and 2 adults. And if I want to make sure that's still the same thing as my 70 people here, remember I said I could do 5 plus 2 is 7, then 10 times 7 is 70, got all my people. Or I could do 10 times 5, that's all my adults, there's my 50 adults, plus 10 times 2, 50 kids, my 10 times 2, that's my 20 adults, and 50 plus 20 is 70. So this is a way to write out that situation using the distributive property. Now, I didn't have to pick 10 groups. I think 10 was my greatest common factor, my GCF. But we also could have done 5 groups, right? I could have done 5 groups. And if I did 5 groups, each group would have had 5 times 10 children to make 50. And 5 times 4 adults to make 20 adults. So that's another way I could just write out that same situation. 5 groups of 10 children, 4 adults. It's the same situation, I just write it out with the distributive property, make it look a different way. We will finish this up tomorrow, so once you have finished writing this one down in your notes and looking back over anything you need to, we'll finish up tomorrow.